Now let's look at the circuit. Let's say we have a circuit like this connected to a load resistance. The circuit connected to the load resistance. The Thevenin equivalent is basically we cut this off, cut whatever the circuit we have, we cut this off and replace that one with V Thevenin and R Thevenin. So the Thevenin equivalent circuit of this one is going to look like this. V Thevenin and then R Thevenin, and here we will have the R load. Okay. And Norton, there's another things like Thevenin circuit also can be drawn as Norton circuit, Norton equivalent. For this one, you have to just take the source transformation. If you watch my last video, I did source transformation. Source transformation is basically if you have a voltage and the resistor in series, you can replace that one with current source and the resistor in parallel. So the Norton equivalent is basically if you do the source transformation for the Thevenin, you will get the Norton equivalent. Now let's look at the Norton equivalent. Here we will have the I Norton and then R Norton in parallel. And here we will have the load resistance. Here one thing is that Norton resistance and Thevenin resistance, both of them are going to be always equal. Okay, that one thing to know. And how to find out the V Thevenin? To find out the V Thevenin, we just take the V open circuit. If we find the V open circuit, that's going to be the value that's equivalent to V Thevenin. How to find out the I Norton? I Norton can be found out by taking the short circuit. I Norton is equal to I short circuit. Okay, these are the basic thing you have to know when you are dealing with Thevenin and Norton equivalent circuits. Here I'm going to do do an example that will actually show how does this work. I'm going to create a new page for it. In this one, let's draw the circuit. Let's say we have a circuit given like this. We have a 6 ohm resistor right here and a 7 ohm resistor right here, and then load resistor right here, load load resistor right here, and let's say we have a 3 ohm resistor right here. 3 ohm 3 ohm resistor right here, and this one is connected with the 12 voltage source. If I draw the equivalent circuit for this one in terms of V Thevenin and R Thevenin, how does it going to look like? If you look at this, so when we have a circuit, what we do is we cut off everything except the R load. So we have to do the same thing here. We cut off everything. We start from here. Cut off everything except the R load and redraw the circuit in terms of V Thevenin and R Thevenin. So this is going to be VThevenin right here. And then here we are going to have the RThevenin. And we are going to have the load resistance right here. Okay. This is the equivalent circuit for this given diagram. Now the next step is how can we find out the VThevenin? VThevenin is equal to V open circuit. If you take the open circuit for this one and solve for it, you're going to get the VThevenin. So let's make this circuit an open circuit. We have to just cut off the RL and make it open. Then find out the voltage across here, and that's going to be the VThevenin. For that one, I'm going to redraw this circuit. Let's redraw 12 voltage and then 3 ohm resistor and then 6 ohm resistor, and we cut off the load resistance, and here we are going to have the 7 ohm resistor, and it's going to be open like this. And this is voltage in the open circuit. Now you can see V open circuit is parallel to 6 ohm resistance. So when you have voltages in parallel, that's equal. So if you find the voltage at 6 ohm resistance, that's going to be the voltage VOC is going to have. So to find out the voltage, you have to just find out the voltage across the 6 ohm resistance. Now let's see how to do it. And also, since we have opened the circuit right here, this 7 ohm is useless because there's no current flow or anything. So this 7 ohm doesn't do anything. So you can just forget about it. And as I see, if I okay, let's redraw this one without the 7 ohm, so you can see this clearly. Plus minus, and this is 12 voltage, and here we have the 3 ohm resistance, and this is 6 ohm resistance, and that 7 ohm resistance does nothing, so I'm gonna just draw a straight line like this. Now from this one, what I can find, I have to find VOC, right? Can I find the VOC? Can I find the voltage across this resistor? Yes, you can see this is the voltage division. Voltage division says that if you have a source voltage provided, and if you want to find out the voltage across any resistor in voltage across any resistor, what you can do is you can multiply this one by the source voltage, that is 12, and then the resistor you are interested in finding the voltage will be on top, and the addition of resistor will be on the bottom. So 6 plus 3, that's going to be 9 right here. So 3 times 3 is 9, and 3 times 4 is 12. 3, and this one is 6, and 3 times 2 is 6. 4 times 2, that's going to be 8 voltage. So the VThevenin voltage, VOC is equal to VThevenin. So the VThevenin voltage is 8 voltage. Now we have the VThevenin. We replace this circuit with VThevenin and RThevenin. We know one value. We found out the one value, that is 8 voltage. Now only one unknown remaining here. RThevenin. How can we find the RThevenin? There's a rule for RThevenin that if the circuit has only independent sources, you have to kill all the independent sources and find R equivalent. So what independent sources we have in this circuit? We have only one independent source, that is this voltage source right here. So we have to kill this voltage source and then solve for the R equivalent. If we kill this voltage, I'm going to create a new page for it, okay? So if I kill that voltage source, it's going to look like this. So we are going to have a straight line here, and others going to remain the same. So it's going to be a short circuit like this, and then 3 ohm and 6 ohm here, And for this one, we had to consider this 7 ohm as well, even though it's not useful. You had to take that 7 ohm also into account and find out the R equivalent. So what is the R equivalent for this? First, you can see all of them are parallel. So 3 and 6 are parallel. Let's take that one. What's R equivalent for 3 and 6? Product over sum. R 6 times 3 plus 6, 6 times 3 over 6 plus 3. That is that is 18 over 9. That is 2 voltage. So I can redraw the circuit like this. This is going to be 2 ohm resistor right here. This is the equivalent circuit, equivalent resistance I found from using this formula. And then we still have the 7 ohm resistance, and these two resistance are in series. So the new resistance we are going to have is, the equivalent resistor we are going to have is 9 ohm resistance. So R equivalent is 9 ohm. The total R equivalent for this circuit is 9 ohm, and that's going to be the R Thevenin. Okay, now we have found out our Thevenin equivalent circuit. We have the V open circuit, that's V Thevenin. We have the equivalent R, that's R equivalent, that's R Thevenin. So that's it, we are done. And if you draw the circuit, this is going to look like this. 8 voltage. So 8 voltage, that's the R Thevenin we solved and found here. And then V Thevenin, that's the V Thevenin, and R Thevenin we found here, that's 9 ohm resistance. And then we have the R load. And that's it. So we actually replace the complete circuit with this V Thevenin and R Thevenin by doing these calculations. Now, if you want to do, like, some people prefer Norton over Thevenin. So you can also convert this one into Norton equivalent circuit as well. How do you convert? You have to do the source transformation. So if I do the source transformation for this one, that's gonna be, when you have voltage and resistance in parallel, the source transformation is going to be the current and the resistance in, these two, when voltage and resistance in series, we are going to have current and the resistance in parallel. And the resistance is going to be same for R Thevenin and R Norton. The resistance is going to be always the same. So this is 9 ohm resistance. Now we have to just find out the current. To find out the current, we can use the Ohm's law. Ohm's law says that V is equal to I times R. I is equal to V divided by R. V is 8. V is 8. R is 9. So 8 divided by 9 is going to be the equivalent Norton current. And once you have got that, that's going to be the equivalent Norton circuit. But you can actually solve this equation and find the Norton circuit as well. How do you find it? Let's see it. Let's see and see if we are getting this one, okay? And we saw one rule in Norton circuit, that is Norton equivalent, that is in the beginning. We say that if we short circuit this load resistance, we can find the Norton current. So let's actually do that. Let's grab the circuit we had. This is the circuit we have, right? I'm going to copy this circuit and paste it in my new page. Control C. Control V. Okay, now I have the circuit. Now what I'm going to do, I'm going to remove the load and make it a short circuit. Remove this load and make it a short circuit, and the current Norton current pass through this. And you can also say I short circuit as well. I short circuit. Now, how can you find the I short circuit? What's the equivalent resistance here? We already did it, right? Like this is the, okay, 3, here if you do the product over sum, this is 2. Here, let's do the product over sum. Let's find the equivalent resistance and solve for the current. Oh, you don't even need that. Let me see if any other short way to do it. If I find the current flowing through this, then I can apply current division. Let's see. So I is equal to V divided by R. V is 12. That one divided by 3. Okay, 12 divided by 3, how much? 4 ampere. So the current going through this one is 4 ampere current. So we know the source current here. Okay. So if I want to find out the ISC, that is I Norton, that's going to be the current dividend. Current dividend says that if you multiply source current by the other resistance, so to solve this one, first I have to do the source transformation first. Okay, in this way, let's do the source transformation and simplify this circuit because it's complicated to solve like this. I'm gonna do the source transformation for this circuit. So here we have 12 and 3. If I do the source transformation, I have to find out the current parallel with the resistance. So if we do the source transformation, this 3 ohm is still going to be there here, and the current is going to be Ohm's law. I is equal to V divided by R. V is 12 divided by 3, that is 4 ampere. So here we are going to have the 4 ampere current, and the 6 ohm resistance is still going to be parallel. And the 7 ohm resistance still going to stay there. Okay, now I can simplify these parallel resistors by doing product over sum. 3 times 6 divided by 3 plus 6, that is 18 over 9, that's equal to 2 ohm resistance. So the equivalent resistance for this one is going to be 2 ohm resistance, 4 ampere, and this one is 2 ohm resistance, and we still have the 7 ohm resistance left right here. Okay, now I can apply the current dividend so easily. Now I have the current source, and then we have the two resistor, and I am interested in the current flowing through the 7 ohm resistor because that's the current that's going to flow through this. We are interested in ISC, short circuit current. ISC, that's the Norton current. So to find out the ISC, we had to just to do the current division. That is, current division says the source current, that is 4 ampere, multiplied by the other resistance. So if I am finding for the 7 ohm resistance, what's the current passing through to the 7 ohm resistance, I had to put this 2 ohm resistance on top. So 2 on top, and then addition of these two resistance, that is 2 plus 7, that is 8 divided by 9. Okay, that's the source current, and that's going to be equal to Norton current as well, I Norton. So we have now the I Norton current. Okay, we have the I Norton current, and let's Yeah, I Norton current is there, and we know that R Thevenin is equal to R Thevenin. We already calculated. So you can see here. This is the R equivalent. We found out the R Thevenin. This same format for R Norton as well. So once you have the current and the resistance, now you can bring it in this pattern. So if we draw the circuit, it's gonna be with 8/9 ampere current. That's the one we have right here as well, right? So you can see, you can directly source transform, or you can find it in this way. And that's basically it. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.